with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist 500 million years.
The launch and deployment of the James Webb Space Telescope marked a turning point in humanity's pursuit to understand the cosmos. For our entire history, we've looked to the stars and contemplated the true size of the universe. With each new generation of technology, the cosmos has revealed itself to be vastly more complex than we had ever conceived. We believed we were grasping the scale of it all. As it turns out, our perspective was profoundly incomplete. With its first major datasets, Webb has unveiled a new vista of the universe, and in one of its largest observing programs, it delivered a single colossal image. This is the Cosmos Webb Field, the largest, most detailed map of the cosmos yet created. Within this frame, which stretches back 13.5 billion years, lies a catalogue of over 780,000 galaxies that are forcing scientists to rethink fundamental theories of cosmic evolution. In the next few minutes, we will journey through this new reality. A reality far more populated and advanced in its infancy than our models had ever predicted. To show you the true staggering scale of our universe, to comprehend the monumental nature of this new map, we must first recall what came before. For decades, our deepest perspective on the universe was defined by the Hubble Space Telescope. Its ultra-deep field, captured in 2004 by observing a seemingly empty patch of sky for over 11 days, was a landmark achievement. It revealed a celestial zoo of approximately 10,000 galaxies, some from over 13 billion years ago, and became our benchmark for cosmic scale. Each point of light was not a star, but an entire galaxy containing billions of its own stars. This single image allowed us to estimate the number of galaxies in the observable universe, a number that grew to a staggering 2 trillion. But Hubble, for all its power, has inherent limitations. It operates primarily in visible and ultraviolet light. The light from the most ancient galaxies has traveled for so long through an ever-expanding universe that its wavelength has been stretched into the infrared spectrum. This is precisely the light the James Webb Space Telescope with its giant golden mirror was designed to detect. It can see through the cosmic dust that obscured Hubble's view and capture this ancient reddened light. And what Webb has revealed doesn't just add to the picture, it redraws the boundaries entirely. To put the leap in perspective into context, if the famous Hubble ultra-deep field were printed on a standard sheet of paper, the new JWST map from Cosmos Webb at the same resolution would be a mural stretching over 13 ft on each side. It is a recontextualization of our place in the universe, as profound as seeing our entire planet for the first time after only ever knowing a single city. The project that delivered this cosmic vista is called Cosmos Webb. It was the largest observing program awarded to JWST in its first year, dedicating over 250 hours to meticulously scanning a patch of sky about 3 times the area of our full moon. The team combined thousands of separate exposures, stitching them together into one seamless, contiguous image. The result is the largest and deepest view of the universe ever captured. A publicly released map containing a catalogue of more than 780,000 distinct galaxies. This map provides a continuous view of galactic evolution from the universe's infancy, just a few 100 million years after the Big Bang, to today, all within a single frame. This isn't merely about seeing more of the same, it's about seeing what was previously hidden and understanding the full context. Where Hubble gave us a glimpse of a busy city block, JWST has provided the entire metropolitan area with its sprawling suburbs and the vast cosmic highways connecting them. It allows astronomers to study not just individual galaxies, but the large-scale structure of the universe itself. The cosmic web of dense clusters and vast empty voids that define our cosmos. The data is so immense and so rich that the science is only just beginning. Let's take a journey through this new map. We are not just looking at a flat image, we are looking through time. The light from the closest galaxies in this image has taken billions of years to reach us, while the light from the most distant has been traveling for nearly the entire age of the universe. Our first stop is in the relatively nearby cosmos, a few billion light-years away. Here we see galaxies in their mature forms, grand spirals, massive ellipticals, and irregular galaxies caught in gravitational dances. Because of the sheer breadth of the cosmos Webb field, we can observe how they arrange themselves into immense superstructures. Recently, within this very field, astronomers found a remarkable object nicknamed the Infinity Galaxy. Two galaxies colliding in a way that formed a figure 8. Extraordinarily, a supermassive black hole appears to be forming not in the center of either galaxy, but right in between them. A discovery that hints at a mechanism of black hole formation, never witnessed before. This is precisely the kind of rare, fleeting event that can only be found when surveying a vast volume of space. Now we journey deeper into the map, further back in time to an era astronomers call cosmic noon. This was a period about 10 billion years ago, when the universe was in its most prolific phase of star formation. The galaxies here are energetic and blazing with the light of young hot stars. Even here, however, Webb is delivering surprises that challenge our models. It has discovered quenched galaxies that have already stopped forming stars, snoozing in an era when they should have been at their most active. It has also revealed remarkably structured spiral galaxies with well-defined arms just a few billion years after the Big Bang. Structures that theories suggested should take much longer to form. These discoveries imply that the processes of galactic evolution were happening far more rapidly than previously believed. This brings us to our final destination, the edge of understanding. Pushing the limits of what JWST can see, we arrive at the cosmic dawn, just a few 100 million years after the Big Bang. The revelations here are paradigm-shattering. Before JWST, our best models predicted that we would find very few bright galaxies in this primordial epoch. The universe, it was thought, needed more time for gravity to gather matter and ignite the first stars. The stunning surprise is that Webb has found a remarkable abundance of bright galaxies at these incredible distances. The record for the most distant galaxy has been broken again and again. First came the confirmation of GDIS Z14-0, a stunningly bright galaxy, seen as it was just 290 million years after the Big Bang. More recently, another was confirmed at an even greater distance, MZ14, which existed a mere 280 million years after the universe began. These are not the small primitive proto-galaxies our theories predicted. They are already luminous systems, and more shockingly, they contain heavier elements like carbon and nitrogen. This suggests that at least one generation of stars had already been born, lived and died, within the first few 100 million years of cosmic history, a timeline that is almost impossibly fast and challenges the very foundations of our cosmic models. The discoveries coming from this new map are forcing astronomers back to the drawing board. If you find the idea that we are witnessing the first draft of a new cosmic history being written as fascinating as we do, make sure to subscribe and hit the notification bell. You won't want to miss what comes next. In essence, what is the true scale of the universe as revealed by Webb? The answer is both a number and a profound recontextualization of our place in the cosmos. The number is almost incomprehensible. A single patch of sky, a tiny fraction of the whole containing over 780,000 galaxies. And within that number lies a universe that is not only larger, but far more complex and advanced at an early age than our theories could account for. We are confronted with a profound puzzle. The sheer number and maturity of these early galaxies challenge the standard models of cosmology. They suggest the processes of galaxy formation and the birth of supermassive black holes may have started earlier, happened faster, or occurred through a mechanism we have yet to conceive. We thought we understood the grand timeline of cosmic evolution, but JWST has shown us that the opening chapters of the story are far richer and more dramatic than we ever knew. This is what it feels like to have the scale of your world change. It's the realization that the universe isn't just vast and empty, but teeming with structure and history at every conceivable distance. For the first time, we are not just seeing faint red smudges at the edge of time. We are seeing a stunning population of bright early galaxies that demand a new explanation for their existence. Thanks to this single massive image, we are the first generation to grasp this new, truer scale of the cosmos. It's a scale measured not just in light years, but in the sheer overwhelming number of worlds and the depth of time they represent. And perhaps the most awe-inspiring thought of all is that even this incredible map, the largest ever made, is just one tiny window. Heat. Hey, heat.